Make It Right, the manufacturing podcast.
Sourcing the necessary materials and parts can sometimes be a challenge for manufacturers, but when it comes to finding the company to produce large-scale, unique, or custom products or parts, it can seem a near impossible and costly search. Aerospace, mining, mills, construction, they often face this challenge, and today's guest on Make It Right serves those industries and more. MetSource bridges a unique manufacturing gap. Their technical understanding enables the sourcing of large, challenging parts in terms of technical specification, size, alloy, and difficulty to manufacture. And they provide deep engineering insight to achieve optimal design that improves part manufacturability for their clients. And their goal is to get it done in a cost-effective and timely manner. John Meyer is with MetSource, and he has helped supply necessary parts and products for such products as the Bay Area Rapid Transit Project in San Francisco and the Seattle Center Arena. So welcome to the Make It Right podcast, John. I'm really anxious to hear about how you run your business and the kind of things that you get to help make.
Thank you for having us, Janet.
My pleasure. So it seems to me that what you do in the manufacturing space is pretty unique. So let's talk about just how you got into this business and what your manufacturing background is.
Well, it is unique. I've been very blessed as I look at, my background in manufacturing and my education that it's definitely provided the building blocks for me to offer value to my clients within the metals industry. So education-wise, I have degrees in metallurgical engineering from the Missouri University of Science and Technology and a master's degree in business, MBA, from Webster University. While I was getting my undergrad in engineering, I had the opportunity to do several interns. And one of the more exciting ones to me was a intern for a commercial heat treater here in the St. Louis area. And that job really gave me the first glimpse into offering consultation to our customers. And as a metallurgist, our group was tasked with performing failure analysis and evaluation of customer supplied parts. And what we would do is evaluate, determine the failure mode on those parts, and then offer suggestions to our customers for material processing or heat treatment changes that they could do to improve the performance of their parts. So that gave me my kind of first glimpse into, offering consultation to our customers. After graduating with my engineering degree, I went to work directly for a sandcast foundry here in St. Louis that manufactures large parts, sandcast parts, and high alloys, performing various roles in manufacturing and engineering. I got a really good kind of overview of the casting process, the benefits of castings, the drawbacks, where a casting may be used more effectively than other methods of manufacture. Eventually, I found myself in a sales role where I really started learning and practicing consultative selling. So what I mean by that is consultative, utilizing my understanding of the casting method, learning my customer's part and application, and then ultimately offering suggestions to improve their product and performance, similar to that role that I had at the commercial heat treater. All those experiences kind of built me up to going on my own and starting this business back in 2004, selling castings initially, but eventually expanding my capabilities into fabricated product, forgings, and now plastics.
Wow. Okay. So I think probably, and I've seen some of these pictures, but I think to give people a real idea of what you can do for a customer, let's talk about the tubing that you help supply for the Transbay Transit Center in San Francisco. Like, this is a showcase transit area. It's this huge glassed-in grand hall where the travelers pass through that is held up by these massive tubing posts. So what was the challenge that the contractor had on this project that you helped solve?
Well, the Transbay project is a perfect example of how my company, MetSource, provides engineered solutions. So these tubes are structural tubes that hold up the entire weight of the structure of the Transbay Center. And my initial discussions with the engineers there were at a construction company's offices here in St. Louis. And they connected my ability for centrifugal tubing with their requirement for this. At that time, all I knew was a huge project to be undertaken in San Francisco. Initially, I was given the scope of the requirements in terms of material specification requirements, the size and number of the tubes, and at that time, the initial challenge was an unacceptable delivery schedule from their current supplier. So initially, that's the information that we were given. With all projects that we kind of undertake, you got to drill down a little bit and discover additional challenges. So one thing to note is the Transbay Center in San Francisco is huge. These tubes are really important, really sizable. We were given strict mechanical properties to meet, which were challenging. So I worked with my manufacturer to to actually develop an alloy with heat treatments to meet the requirements of the project's mechanical strength on these tubes that would withstand that weight of the structure. The tubes, size-wise, were 32 inches in diameter and several inches in wall thickness. But the big thing was the length of these tubes. So the shortest tube, depending on the placement and the structure, these tubes were varying in lengths from 15 feet up to 47 feet in length.
Wow.
There's no one in the world that can make that diameter and that length. So my capability through my centrifugal foundry, which is unique, is that they can make a length up to 36 feet length. The forger that they originally went to could only make it in 13-foot length. So I was able to eliminate some of the expense in weld seams. And as we were drilling into the engineers on the projects and the designers and the architects, what we found was the tubes that were exposed to the public that are visible, there's an aesthetic appearance that they wanted to limit the number of weld seams. So not only did we have to meet the mechanical properties and the size requirements, but limiting the number of welds is ultimately what won me that project.
Wow. And, I'm going to throw you a curveball here, John. So tell me if you have an answer for it or not. But I'm thinking we're talking San Francisco. Is there some concern about earthquake and stability and structure? Or is that an engineering thing that you didn't have to really worry about?
Thankfully, I didn't have to worry about that, but there are engineered designs that account for earthquake, up to a certain limit. Those are handled in the base of the structure. All my tubing was more into the floors of the structure and then supporting the overall roof structure. So fortunately, I didn't have to deal with the base structure and the earthquake concerns, but anything in those earthquake specific zones, they have specific engineering that goes into the base structure that accounts for that.
Mm-hmm, mm-hmm. So your business, you have manufacturing partners that you pair with a project to create what's needed. So these manufacturers, they do the casting, the forging, fabrication, the machining in the metals or the plastics. They're sometimes sourcing very specific materials for unique projects, correct?
Oh, most definitely, yes.
Yeah,
So
okay.
materials are obviously of great interest to me with my engineering background, but also I think people fail to realize over the last 20 years, the development in alloys and materials that we've encountered have, specifically for specific applications. Now, this is driven by aerospace and automotive. They're looking for stronger materials and lighter weights, obviously for fuel consumption reasons. But when I tell people that we take stainless steel for granted, as a society, but when I tell people that it was only developed 100 years ago, the addition of chromium to steel to produce stainless steel, that was invented in 1913. That wasn't very long ago. In fact, 80% of the world's alloys have been developed in the last 20 years. That's pretty amazing to think of. So that's what really drives, my interest in materials. But also, it's important to note that even though automotive and aerospace is kind of driving this, there's also developments in materials for all the other industries as well. And that's where my company comes in.
So are you actually creating some of these new alloys? I mean, I know you said you had to do something specific for the San Francisco transit system, um, or transitway. So are your manufacturers actually, you're working with them to come up with these new alloys?
We do in very specific circumstances. So one example, we provide some valves for oil and gas. And these alloys are going either, depending on the application, there may be a sour gas well very deep into the ground. We're developing alloys similar to Inconel that would withstand that corrosion. We're providing materials to NORSOC certification for the North Sea. So that's valve components that are going into seawater corrosion application. And yeah, we're either tweaking existing alloys for that customer's benefit, or we're creating our own alloys to service our clients' needs.
Wow. And can you also offer support to your customers with alternative design solutions or modifications in the actual product that they want to make so you can help them reduce cost and maybe get things out there for them faster?
That's what we do. Most definitely, yes. So that's what we do on a daily basis. So,
Okay.
these design modifications, they're not overhauls of the design. So our customers actually they're the OEMs, they own the design, own all the rights. What I'm really talking about is I understand the process to manufacture to their design. So I'm offering maybe a design tweak, a radius here, a rib there that would help in the manufacture of their parts or help within the service of their parts. So it's really my knowledge of how to manufacture and then looking at their design to help them create a better product for their service. And one example that I can give you is and this goes back several years, we provided a tube for a heat treater who does a continuous heat treating process on some tungsten filament process. And he was getting a pretty short life. Now this tube's huge. We're talking 18 feet long and 3 feet in diameter. And it's used to process, size of this tungsten is up to a baseball size in diameter down to just powder. And it all goes through this tube and it is heat treated. Well, we put lifters in this tube to kind of make sure that product, that tungsten, was getting accurate heat treatment during the process as it flows through the tube. But their failure mechanism was actually the sizable product was impacting the tube and causing cracks. So we just included ribs both around the diameter and then lengthwise that actually strengthened the tube wall to give them longer life. And they went from initially a 12-month life to a 36-month life. So that's just one example of us improving their performance of their part or their product by just adding an engineered solution.
Wow. I'm thinking about some of the other key challenges that you've been able to address. And you've talked about the aerospace industry and, the need for things that are a little bit lighter because of, fuel consumption and things like that. I don't know whether this relates to it or not, but you did do an interesting project in the aerospace sector. Can you explain how that went?
Yeah, so very recently I was approached by a design engineer at a tier 1 supplier to aerospace. And he wanted to create some vane axial fan components. And he was looking for prototypes at this point. And he approached me, and we're talking vanes on a impeller where the placement and pitch of those vanes are very important to airflow. His initial thought was he wanted to investment cast these, but after looking at the number that he wanted of parts just initially as prototypes, it was actually a better recommendation to use a 5-axis CNC machine to produce those out of a round aluminum bar and use those as his prototypes to go through the design engineering so he could do his airflow measurements and whatnot. And then as that becomes a production project, then we will switch it to an investment casting where we can make thousands of those for his eventual use in recirculation air on airplanes. But Right now, that project's waiting approval based on his kind of design studies, but that's one example within aerospace. Uh, Aerospace is important to us because they're really the ones seeking out engineering solutions.
Hmm.
They're using materials that kind of match up with my company. There's a large density of aerospace customers in my area. So the aerospace industry is important to both me and my manufacturers for development. And I've been fortunate to work on several projects for the aerospace industry.
Yeah, and I guess there's specifications like we talked about lightness, and you just like they can't have a failure rate when we're talking about something in the air. You don't want any failures. So I guess the challenges are quite significant with aerospace.
There's no doubt. So we call it mission critical, but some people call it life or safety critical, where these parts cannot fail.
Hmm.
We're making landing gear bushings. Obviously, that's controlling the wheels that touch down so you can land the plane. Um, those components, just for safety reasons, obviously can't fail. So yeah, there's definitely a quality uh, uh, component to aerospace.
You talk about, you're creating these really unique parts, things that, you may not have ever even thought of having to figure out how to get these things made before. And you're creating them in a timely and a cost-effective manner. Like I'm curious about, how much time can you save somebody who's looking for a product, and, how much, of a cost impact can you have on some projects? Can you share a story about how you've been able to do that?
Well, each specific application is different. For the petrochemical industry, a day's worth of shutdown, if they have unplanned shutdown due to a part failure, that could cost them $1 million a day.
Hmm.
Other manufacturers, it's not quite that impact, but they still, schedule integrity is important to them, just for customer satisfaction. So it may not be $1 million a day, but it may be thousands of dollars an hour that they're losing in opportunity costs. But we deal with being in the manufacturing industry, we deal with these unplanned shutdowns or failures all the time. And I'm blessed that my manufacturers recognize that my customers need product, in an expedited fashion. One example recently was a mill here in the St. Louis area had a shortage of parts because their supplier was shut down due to the COVID mandate from their governor in their state.
Hmm.
And they asked us to cast some large copper castings, 500 pounds each, in an expedited fashion. Well, I didn't even have a pattern to create those casts. We had to modify a pattern. We had to get it. We had to get the material in, uh, delivered to us. We had to cast it, finish it, machine it, ship it to them, and we did that in 3 weeks. Uh, Normally, something along those lines would be measured in months. So, my manufacturer really stepped up to the plate, was able to perform magic on that project, and we essentially saved our client tons of money.
Wow. When I think of unique manufacturers and unique projects that they're working on, the first person who always comes to mind is somebody like Elon Musk. Um, you know, I bet you'd love to have a call from him sometime, right? Come on, create me something, right?
Well, no doubt. So, Elon, with SpaceX, Tesla, and Boring Company, they're all examples of him pushing technology to its limits. It's kind of incredible to think of, or a self-driving car. 10 years ago, that would have been fantasy, but with Tesla, now we have it, right?
Hmm.
So we could all learn something from his work ethic, his results in business. Very recently, I did a posting on LinkedIn where Tesla had done something where they had garnered some national attention. So the project is where Tesla had a series of robots installing, gluing, assembling 70 components into a rear underbody assembly for one of their cars. And they made a decision to actually take out all those robots, it wasn't necessary, and replace all those components with one singular aluminum casting. And it got me thinking, I posted this on LinkedIn, that's exactly the engineered solution that my company provides. It's an example of thinking outside the box. How do you improve your manufacturing process by, either replacing an assembly with one part or thinking of a better material or of a better way to manufacture your end product. And, a company that's so well managed like Tesla and so highly engineered, if they have examples, and in fact, Janet, they're looking at other parts of this same component or car and other models to do the same sort of solution to. This project was so successful, I read in this LinkedIn article. But if Tesla can find opportunities like that, any manufacturer, can find those sort of opportunities. And that's the space that my company, MetSource, deals within, trying to find a better way to produce a product.
Well, and if you think about that, and who knows what the numbers are for Elon Musk and Tesla, but if you only have that, you have that one part as opposed to all of those other components, like how much of a time saving factor is that for them now? Like it's huge,
it's unfathomable.
Right?
It's unfathomable. They must be saving millions of dollars without having to operate those robots with, just the cost of 70 components to one. They're saving lots of money.
John, this industry, you're talking to manufacturers all the time, you're creating these unique components. Do you have any key takeaways that you want to leave with the listeners about how they can think about their manufacturing projects and processes and what they're doing to improve them?
I think it's important to talk to engineers outside your company, because you get kind of into, this is the way we've always done it. And a set of fresh eyes on a part or a process could offer a new perspective. And that's really, what I'm doing is not, it's only taking what I've learned from other applications and just applying it to new applications. It's not earth-shattering. If we have an issue with one out, it's basically performing failure analysis and finding the reason why something fails and improving it so it doesn't fail in that mechanism anymore. That's basically what it boils down.
Mm-hmm. Mm-hmm. And all of this research and development, and I'm going to lead this into a podcast I'm going to do in a couple of weeks, though, but all that research and development that a manufacturing company does can lead into tax credits for them, right? So it's not a sunk cost that you never get the return out of.
You're exactly right. So the benefits of this one change, of this little R&D investment, could be forever. It could be years and years, and you could get tax breaks. You could obviously get the benefit of eliminating 70 components to one. It's unlimited, the amount of benefit you could get from thinking in this way.
Yeah. John, really a pleasure to talk to you about MetSource and what you do. And I wish you continued success. It sounds like a really cool business.
Thank you so much, Janet. Appreciate our time.
Oh, my pleasure. John Meyer is the owner of MetSource. They're a manufacturer's representation agency, and they work on some really cool and huge projects. That's our show this week. Please check out our Twitter and LinkedIn feeds that are on our podcast page. Subscribe and share if you like the podcast with your friends and colleagues. We're on iTunes, Google Play, Stitcher, Spotify, and YouTube. And the Make It Right podcast is brought to you by Kevin Snook. He's a leadership advisor and author of the best-selling book, Make It Right, 5 Steps to Align Your Manufacturing Business from the Front Line to the Bottom Line. Until next time, I'm Janet Eastman. Keep thinking outside the box, and thanks for listening to Make It Right.